So these are just toys?
Well, toys and experiments. You know, experiments are much more interesting.
What about experimental toys?
Better still. Better still, yes.
Experimental toys. So how many volts does it take before it actually starts to hurt and get painful?
Richard, what we really need is a volunteer. Then we can find out about this, you know, how we feel electricity. I wonder if you possibly know someone who could volunteer, sort of someone who's very, very interested in doing experimentation. Sort of,
I do know a guy, yeah. I'm sure he would be very keen to do an experiment like this.
Oh, wonderful.
I'll just see if I can go get him.
Oh, terrific, yeah.
So, you're the one who wanted me for an experiment, did you?
I would like to have someone for an experiment, a scientific experiment. You're very keen, I believe, in that sort of thing, are you?
Oh, yes, absolutely.
Good. Now this is about electricity.
Oh, yeah, okay.
You're not afraid of electricity, are you?
No, of course not.
Okay. Well, this here is an instrument that shows you how much voltage you can take before you die. I mean, before you feel anything, you see.
Okay.
You take these two handles, one for each hand, put them into your hand, right?
Yes.
And now I'm going to start turning. And you can see the voltage here on the instrument. I start turning, and you tell me as soon as you feel something, you let me know, right?
Okay.
Okay. You can't now, can you?
No.
Good. That's 12, this is 15 volts. Now we're going to 20. What about now?
I can feel something now.
You can feel something now. Can you describe it?
It feels sort of like a tingly feeling.
A tingly feeling.
muscles
All
are
right, this is 20 volts. Now, I'm going higher up to, this is 30 volts. How's that? How's it feel?
Weird.
Yes? Can I go higher? Now, how are we going now? This is 40, 45 volts in fact.
Ow.
Yeah,
That really hurt.
that really hurts. So 45 volts hurt. Okay. Well, thank you very much for your experiment. That's very good.
I hope he didn't get hurt too much.
I don't think so, because he could have dropped it, you see. But the important thing is, once you go above this voltage, you know, more than this machine can do, 80 or 100 volts you cannot let go. You are virtually paralyzed. And that is the danger in electricity. And that is how important we have to know what we mean by voltage. You see, so and so many volts will give us a certain effect. Now, if we go 60, 70, 80, we cannot let go anymore because our nerves, our muscles are paralyzed.
So does that mean that by putting through a lot of electricity, you're actually tensing up your muscles?
Yes, you grab it, possibly even more, you see.
Okay. So, how many volts was Mark using when he was making these switches?
I'm not sure. I think 6 or 12 volts. You know, that was not too much. Incidentally, using those switches here, we can build a simpler computer still, you know. Have two switches, I'll show you. Here is an AND gate. We take these two in series and connect them, like so. And now, if I take an umbrella, no good. If I take a raincoat, no good. If I take an umbrella and a raincoat, we can go. Fantastic, isn't it? Take the other one. Now, if we now change this, you can change this into an OR gate. We put these two switches in parallel. And we may be asking, here's one, here's the other one. Oop, one is open. If I take the key and lock the door, yes, I can go. If I leave the key at home and leave the door unlocked, yes, I can get back in again, I can go. The OR gate, see? Well, here we have one that is a bit more sophisticated. It's got an OR and an AND gate, all on one board.
That's a bit complicated.
Yes, looks a bit complicated at first. Now, we can simplify it if we use a diagram. Let's go over and have a look at the diagram. This is a diagram of only the lower half, the OR gate. As you can see on the left-hand side, we have a buzzer and a light. And of course the lines represent the wires. And you can see the open switch, and here is the real thing. Now let us have a look at the other gate, the upper one, the AND gate. Here again we can see the switches, both switches are open, and here is the real thing, so we're only looking at the AND gate now. Now if we look at the two together, here is the diagram, and now we can understand much more easily how they represent all the functions of those two gates.
The diagram makes it easy. Now I can see how it all works.
Yep. This one here now, of course, has a buzzer and a light, just to make it easy. Let's think of another program. Let's assume little Johnny, he doesn't always eat his vegetables. He gets his dessert if he eats his vegetables. Yes. Or his potato. Okay. But now Johnny's going next door and they have a different rule. He eats his vegetable? No good. He eats his potato? No good. He eats his vegetable and his potatoes. He can have dessert, you see. Now, if you multiply this simple model 1,000,000 times and that's 1,000,000 times again, that's what is necessary to build a computer. And it is all coming back to
many electric circuits.
Many electric circuits, switching off and switching on. Here's another one. You see, it is called a continuity meter. Now, if we put these two together, there's a noise. So if you wish to know if something is conducting, you just see if it closes the circuit or not. Now, this is a piece of aluminium foil, isn't it? Clear. So this is obviously conducting. No, it's not, because it is plastic. Looks like
aluminium foil, though.
Here is a piece of lolly paper. Now, see if this is conducting. Aha!
So that is
metal. What about the other side? Not conducting. Interesting.
Plastic.
Here's another piece. Here again, we don't know if it could be aluminium foil, could be anything. Try this one.
You can't get me with the same trick twice,
No.
Peter. I know that's plastic.
We have here, this is a beauty, a black piece of rod. Do you think it's conducting, yes or no?
It looks just
Okay.
like plastic.
You'll find out. There and here.
Hey!
It is conducting, yes, because this is a carbon fiber rod. You see, and carbon conducts.
When the switch is opened,
Oh, not again.